Hello, we will be presenting Chapter 10, The Revolutionary Era. Background of the Revolutionary Era during the 17th century. The Revolutionary Era during the 17th century saw a rival blowout of mathematical and scientific ideas across Europe, which is a period sometimes called the Age of Reason. The 17th century also witnessed the consolidation of Copernican heliocentric astronomy and the founding of initial physics from Johannes Kepler, Galileo Galilei, René Descartes, and Isaac Newton. The 17th century is one of the intense activity and innovation in mathematics because of the advance in numerical calculation, the development of symbolic algebra, analytic geometry, and integral calculus resulted in a major expansion of the subject areas in mathematics. Algebra and number theory. The symbol and equation with symbolic coefficient was founded by François Viard and René Descartes. René Descartes introduced the modern notation and showed that the problem occurring in geometry can be expressed and solved in terms of algebra. In his geometry, Descartes proved the factor theorem, namely that if it is a root of the polynomial, then x minus a is a factor. Repeating this process, it follows that a polynomial of degree n has exactly n roots by induction. Descartes' rule of signs. The number of positive roots of a polynomial does not exceed the number of changes of signs of its coefficient, and the number of negative roots is at most the number of times similar signs become consecutive. The fundamental theorem of algebra. Every complex polynomial of degree n has exactly n roots. Another simple way to state the theorem is that any complex polynomial can be factored into n terms. The first formal attempt to prove the theorem was by Albert Girard in a 1629 publication entitled The Invention in Algebra. He did not understand the nature of complex numbers, and this was to have implications for future exploration of the problem. Then, Leibniz claimed to prove that the fundamental theorem of algebra was false, as shown by considering x to the power of 4 plus a to the power of 4, which he claimed could not be written as a product of two real quadratic factors. His error was based on misunderstanding of complex numbers. In 1742, Leonhard Euler showed that Leibniz's example was not correct. Leonhard Euler proved the fundamental theorem of algebra polynomial of degree up to 6. Bernoulli claimed that the polynomial of degree 4 cannot be further factorized, and hence fundamental theorem of algebra is not true. In 1747, Leonhard Euler succeeded in disproving Nicholas II Bernoulli's claim. In 1749, Euler proved a general result that any real polynomial of degree 4 can be factored into quadratic factors.